Hello children, today we will start the chapter electricity. This is the first chapter of your 10th class syllabus of subject physics and science. First we'll discuss what is electricity. Electricity is a form of energy which enables various electrical devices like electric fans, electric motors, electric geysers, electric heaters. All those devices work on a form of energy, and that is known as electrical energy. This electrical energy flows through the conductors. So the conductors are the substances through which the electricity can pass easily. This definition is in your previous classes as well. Electricity was discovered by Greeks in ancient times. As we all know, when we rub a plastic comb with a dry hair and that rubbed plastic comb brings near the piece of paper, then both will get attracted. The piece of paper will get the positive charge and the plastic comb will get the negative charge. Due to those opposite charges, they attract each other. And electricity is all about these charges. Now we'll discuss what is electric charge. Electric charge is a property of any substance due to which it has a polarity that is known as electric charge. Electric charge's unit was given by a scientist, Coulomb, and it is represented by capital C. This is the SI unit of electric charge, the standard international unit of electric charge. Electric charges are represented by Q. So charge on any object is represented by Q. Next, we have to discuss the properties of charges. What are the properties of charges? The two properties which we have discussed was very common, that same charges repel each other, or like charges repel each other. एक जैसे चार्ज पॉजिटिव और पॉजिटिव, नेगेटिव और नेगेटिव एक दूसरे को क्या करेंगे? रिपेल. Whereas the opposite charges attract each other. That is, unlike charges attract each other. In this class, you will study another property that is known as quantization of charge. What does this mean? Quantization of charge means charge on any object. Let Q is charge on any object X, any object A. The charge on any object is a whole number multiple. It's a whole number multiple of minimum possible charge, and minimum possible charge is a charge on an electron. So the electric charge is a whole number multiple of minimum possible charge, and the value of minimum possible charge is 1.6 into 10 raised to the power minus 19 coulomb. This value you must have to remember. If someone asks you what is the minimum value of electric charge, the minimum value of electric charge is equals to the charge on an electron, and charge on an electron is 1.6 into 10 raised to the power minus 19 coulomb. I am again explaining you this property. What is quantization of charge? Quantization means amount of charge. The amount of charge on any object is a whole number. What is a whole number? Complete number, like 1, 2, 3, 4, 5, 6, 7, 8 and so on. The number which is not in fractions. 1 by 2, 3 by 4. These are fractions. This number, this multiplier must be a whole number. 1, 2, 3 and so on. Millions. But that number must be a complete number. Whole number multiple of minimum possible charge, and that minimum possible charge is the charge on an electron. Now we will discuss the application of this quantization of charge. This quantization of charge application is, it helps us to find the number of electrons in a given unit of charge. For example, there is an NCERT question in your book that how many electrons are present in 1 coulomb of charge. If 1 coulomb of charge is flowing through a conductor, then tell the number of electrons passes through it. So bache, in this sum, the given thing to us is electric charge. What is electric charge given to us is 1 coulomb. We know the charge on an electron is minimum possible charge, that is 1.6 into 10 raised to the power minus 19 coulomb. According to quantization of charge, Q is equals to M into E. That is, charge on any object is equals to the whole number multiple of charge on an electron. So let's say the charge here is 1 coulomb. We put the value 1. Number of electrons we have to find, and electron charge is equals to 1.6 into 10 raised to the power minus 19. This is a multiplier. Here it comes as a dividend. Number of electrons is equals to 1 by 1.6. This minus 19 will goes above and become plus 19. When we solve it, it will be equals to 6.25 into 10 raised to the power 18 इलेक्ट्रॉन्स. जब बच्चे हम इसे सॉल्व करेंगे 1 by 1.6 करेंगे तो यह वैल्यू आ जाएगी 6.25 into 10 raised to the power 18 इलेक्ट्रॉन्स. आप इसे सॉल्व कर सकते हैं, तो इसे सॉल्व कर लीजिएगा. सो द नंबर ऑफ इलेक्ट्रॉन्स in 1 coulomb of charge is equals to 6.25 into 10 raised to the power 18 electrons. 1 coulomb चार्ज में इतने इलेक्ट्रॉन्स होंगे. और उनको कहे 2 coulomb चार्ज में निकालो तो मल्टीप्लाई बाय 2, 5 coulomb में तो मल्टीप्लाई बाय 5. That's how we can use the quantization of charge. Now we will discuss a very important topic for your board exam, that is electric potential. Before understanding this topic, we must have to know one term, that is electric force and electric field. Let us suppose it is a charged object and it has a charge plus Q. It is a charged body and it has a charge over it, and that charge value is plus Q. So bache, as we all are aware beta, that charges always exert a force on another charges. If there is a positive charge around it, another charge, it's Q2, it will exert a force of repulsion over it. And if there is another charge, let us suppose that charge is minus Q3, that is of opposite polarity, then they will attract each other. So there is a force now, whether that force is of either of repulsion or of attraction. But there is a force, and that force which is exerted by a charged body on another charged body, that force is known as electric force. Now we'll discuss the electric field. This is the electric force which, let us suppose it is a charged object. It has a reason around it. It is a hypothetical reason. In your higher classes, you will study that actually that reason exists just above the conductor. Let us suppose it is an electric wire. If you place your hand very near to it, then also you don't feel the electric charge, electric field over you. You will feel the electric force, electric field only when you touch the wire. But still, in physics, it is considered, in the physical quantity, it is considered that there is a hypothetical reason around this charge in which it exerts a force of attraction or repulsion over another charge. That region around it is known as electric field. So there are two things. One is electric field, the region around a charge in which it exerts a force on another hypothetical charge. That region is known as electric field. And the electric force is the force exerted by a charged body on another charge. That force is known as electric force. So let's say, now we'll discuss the electric potential. Electric potential is the work done per unit positive charge in bringing that charge from infinity to that point. In the electric field. There is some specific thing about the electric potential. First thing is, it always lies in an electric field. Electric potential is always lies in the electric field. Second thing, it is a point in the electric field. It is a very small point in the electric field. Next thing, it is always represented as the work done per unit charge. Whensoever we bring a unit positive charge, let us suppose this is an electric field, which is a conducting wire. This is a charge. This is a unit positive charge around it. Let us suppose this is the electric field. This is the hypothetical electric field. Actually, it does not exist. We want to find the electric potential at this point. This point is A, and this point must have to lies in electric field, and it is present in electric field. We are bringing that unit positive charge from that to this point, from this place to this. This is infinity. This distance is infinity. So when we are bringing a unit positive charge from infinity to a point in the electric field, then work done per unit charge in bringing that. As you all know, the work done is equals to force into displacement. There is a force of attraction or repulsion. That means if there is a force and it is moving, that means there is displacement as well. And if there is F and S, that is force and displacement, there must be a work done. So work done in bringing a unit positive charge from infinity to a point in the electric field is known as electric potential at that particular point. इलेक्ट्रिक पोटेंशियल क्या है बच्चों? ये एक पॉइंट पर, कौन से पॉइंट पर? जो इलेक्ट्रिक फील्ड में है, उस वर्क डन को बोलते हैं जो हम एक यूनिट पॉजिटिव चार्ज को, किसे? यूनिट पॉजिटिव चार्ज को इन्फिनिटी से उस गिवन पॉइंट पर लाने में कर रहे हैं. मान लो हम उसे ए तक ला रहे हैं, तो दैट इज इलेक्ट्रिक पोटेंशियल एट ए. मान लो मैं इसी पॉजिटिव चार्ज को इस पॉइंट तक ला रहा हूं बी तक, तो जितना वर्क डन मुझे करना पड़ेगा पर यूनिट पॉजिटिव चार्ज, दैट इज नोन एज इलेक्ट्रिक पोटेंशियल एट बी. मान लो एक और पॉइंट है बच्चे सी, इलेक्ट्रिक फील्ड में ही है पॉइंट, मैं इसे यहां से यहां तक ला रहा हूं, तो दैट इज नोन एज इलेक्ट्रिक पोटेंशियल एट पॉइंट सी. तो बच्चों, द फॉर्मूला ऑफ इलेक्ट्रिक पोटेंशियल वुड बी इक्वल्स टू formalizing its definition, work done per unit means divided by charge. We always take unit positive charge for the standardization of the unit. There is nothing specific about the positive charge, but just we are taking the positive charge for the standardization. So the formula of electric potential is work done per unit, that is divided by charge. Electric potential is represented by V, work done is represented by W, and charge is represented by Q. So the formula of electric potential is V is equals to W by Q, that is work done by charge, work done per unit charge. The unit of potential difference, or you can say electric potential, is volt. The unit of work done is joule, and the unit of charge is coulomb. If it is 1, it is also 1, then automatically it will be equals to 1 volt. So if someone asks you what is 1 volt electric potential, then the answer would be if 1 joule of work is done in bringing 1 coulomb of charge or 1 coulomb of unit positive charge from infinity to a given point in the electric field, that is known as 1 volt electric potential at that particular point. 1 volt potential इलेक्ट्रिक पोटेंशियल क्या होगा बच्चे, जब हम 1 जूल वर्क करेंगे 1 कूलम चार्ज, 1 कूलम यूनिट पॉजिटिव चार्ज को इन्फिनिटी से उस पॉइंट तक लाने में जो पॉइंट इलेक्ट्रिक फील्ड में है, दैट इज नोन एज 1 वोल्ट इलेक्ट्रिक पोटेंशियल. एंड इट्स अ वेरी वेरी इंपॉर्टेंट टॉपिक फॉर योर बोर्ड एग्जाम क्वेश्चन बच्चों. Now we will discuss another very important topic for your board exam, that is potential difference. This is a charge body, which this is its electric field, and this is point A and this is point B. We are bringing a unit positive charge, that is plus Q, from B to A. We have to do a certain work better, and there is a charge to which we are pulling or which we are pushing. There is a force either of attraction or of repulsion, either of pull or either of push. So the work done in bringing a unit positive charge, that is work done per unit charge from one point in the electric field to another point in the electric field is known as potential difference at that particular point. बच्चे इलेक्ट्रिक पोटेंशियल क्या था, ये चार्ज बॉडी है और मैं एक पॉइंट पर चार्ज ला रहा हूं, बट दैट चार्ज इज कमिंग फ्रॉम इंफिनिटी, फ्रॉम आउटसाइड द इलेक्ट्रिक फील्ड. बट इन पोटेंशियल डिफरेंस, द पॉइंट फ्रॉम विच वी आर ब्रिंगिंग द चार्ज and the point at which we are finding the potential difference, at which we are taking the electric charge, both the points are present in the electric field. इलेक्ट्रिक पोटेंशियल में क्या था बच्चे, एक पॉइंट जिससे हम चार्ज ला रहे हैं वो इलेक्ट्रिक फील्ड से बाहर था, और जिस पॉइंट पर हम इलेक्ट्रिक चार्ज ला रहे हैं वो इलेक्ट्रिक फील्ड के अंदर. लेकिन पोटेंशियल डिफरेंस में क्या है, जिस पॉइंट से आप चार्ज ला रहे हो वो भी इलेक्ट्रिक फील्ड के अंदर है, और जिस पॉइंट पर हम पोटेंशियल डिफरेंस निकाल रहे हैं दैट पॉइंट आल्सो लाइज इन द इलेक्ट्रिक फील्ड. सो व्हाट इज द डेफिनेशन ऑफ पोटेंशियल डिफरेंस? The potential difference at a point in the electric field is the work done per unit charge when you bring that charge from one point in the electric field to another in the same electric field. जबकि इस केस में क्या था, from infinity to other point in the electric field. Rest all things are same बच्चे. Potential difference is also represented by V. Electric potential is also represented by V. The formula of electric potential is V is equals to work done upon charge, W by Q. The formula of potential difference is also the same. So the formula of potential difference is V is equals to W by Q. The unit is also same, one, that is volt. Volt will be equals to joule per coulomb. If it will be 1, both of them also become unity. So the potential difference is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb unit positive charge from one point in the electric field to the another point in the same electric field. That is known as potential difference. A very important question for your board exam. Define 1 volt of potential difference. Now we will discuss what is electric current. Flow of charge per unit time is known as electric current. Whensoever charge flows through a conductor in a given unit of time, that is known as electric current. So flow of charge per unit time is known as electric current. So according to this definition, electric current is equals to electric charge per unit means divided by time. So electric current is flow of charge per unit time. Electric current is represented by I, capital I. Charge is represented by Q and time is represented by small t. So the formula of current is Q by T, that is charge per unit time. Standard international unit of current was placed on the name of scientist who discovered it, that is ampere. Ampere is equals to Coulomb, the SI unit of charge, divided by the SI unit of time is a second. So ampere is represented by capital A, Coulomb by second. This is the unit, SI unit, standard international unit of current is ampere. What is 1 ampere? If both of these units would be unity, it would be 1. So what is 1 ampere current? The current flowing through a conductor is said to be 1 ampere. एक कंडक्टर में से जो करंट फ्लो हो रहा है उसको हम 1 एम्पियर कब कहेंगे? When or if 1 coulomb charge passes or flows through that conductor in 1 second. जब एक कंडक्टर में से 1 coulomb चार्ज पास हो जाए कितने सेकंड में? 1 सेकंड में, then that current is known as 1 ampere. अब इसे और मॉडिफाई कर सकते हैं आप. कितने इलेक्ट्रॉन पास हो जाएंगे? 1 कूलम में कितने इलेक्ट्रॉन्स होते हैं? 6.25 into 10 raised to the power 18 electrons. That means if 6.25 into 10 raised to the power 18 electrons are passed through a conductor in 1 second, then the current flowing through it is referred as 1 ampere. Another one mark, a very important definition for your board exam. What is or define 1 ampere? Define the unit of current. The unit of current is 1 ampere. What is 1 ampere? The electric current flowing through a conductor is said to be 1 ampere if 1 coulomb charge passes through that conductor in 1 second. So that is the definition of 1 ampere. Rather than this, there are other units also. The smaller unit of current is milliampere. That is small ampere. 1 milliampere is equals to 10 raised to the power minus 3 ampere. So that is the smaller unit of current. 1 milliampere is equals to 10 raised to the power minus 3 ampere. Next we will discuss how does a conductor conducts electricity, or how a continuous flow of electric current is maintained in a conductor. बच्चों, a conductor is a substance which has certain free electrons. You must have heard that metals are the best conductors of electricity, like silver, copper, aluminium, iron. All these are metals and they are the best conductors of electricity. Why the metals are the best conductors? Because metal possesses free electrons. These free electrons are moving continuously in random directions. सब random directions में move कर रहे हैं बच्चे. But when we connect a fixed potential difference around its ends, हमने क्या किया? एक फिक्स पोटेंशियल डिफरेंस लगा दिया. अब क्वेश्चन यहां से एक बनेगा क्या? हाउ डू वी कनेक्ट, हाउ डू वी गेट अ फिक्स्ड पोटेंशियल डिफरेंस अक्रॉस द एंड्स ऑफ अ कंडक्टर? दोनों एंड्स पर हम एक फिक्स पोटेंशियल डिफरेंस लाए कहां से? द फिक्स पोटेंशियल डिफरेंस इज मेंटेन्ड बाय अ सेल और बाय अ बैटरी. A cell or a battery has a fixed potential difference. At one end, the cell has 1.5 volt, at the other end is 0 volt. So 1.5 minus 0, the total potential difference is 1.5. If this hand has a potential difference, potential of 110, this has 330. Then what is the potential difference? 330 minus 110, 220 volt. Let us suppose this is 10 volt and this end is having 20 volt. What is the potential difference between the two ends? 20 minus 10, 10 volt. So by connecting a cell, we get a fixed potential difference. And due to that fixed potential difference, these electrons will align itself, will arrange itself in a fixed direction. And that direction is from their higher potential to their lower potential. Charges always flows from their higher potential to their lower potential. नेगेटिव चार्ज इलेक्ट्रॉन है बच्चे, इलेक्ट्रॉन का पोटेंशियल यहाँ ज्यादा है, तो इलेक्ट्रॉन चलेंगे नेगेटिव से पॉजिटिव की तरफ. अब इसमें प्रोटॉन्स भी होंगे, या भी एक पॉजिटिवली चार्ज आयंस भी होंगे, वो चलेंगे बच्चों फ्रॉम पॉजिटिव टू नेगेटिव. वो हम रिप्रेजेंट नहीं कर रहे हैं इस डायग्राम में, बिकॉज जनरली we associated the flow of charge with the flow of electrons only, because the ions are quite large size particles. They move very slow. Electrons are also moving very slow, but their movement is measured. Whether it is very slow, but that movement is measured, and that is what the flow of charge is. The movement of electrons is basically considered the flow of charge. So how does a conductor conduct electricity? A conductor has free electrons which are moving randomly here and there. When we connect a fixed potential difference around the ends of a conductor, then those free electrons will align itself in a fixed direction, and that direction is from their higher potential to their lower potential. So one thing we must have to keep in mind, that charges always flows from their higher potential to their lower potential. And whenever a charge starts to flow, time is also moving with the flow of charge per unit time is known as electric current. Charge flow होने लगा बच्चे, और उस flow of charge को per unit time के साथ क्या कहते हैं हम? इलेक्ट्रिक करंट. मतलब इलेक्ट्रिक करंट फ्लो होने लगा. अब इलेक्ट्रिक करंट लगातार फ्लो क्यों हो रहा है? क्योंकि हमने एक फिक्स्ड पोटेंशियल डिफरेंस इसके साथ कनेक्ट कर दिया है.